Hello viewers. Today in these sessions, we are going to discuss about the multiplexer. We all know the multiplexer is a type of the combinational circuit. So before we going to the multiplexer, the first question which is come in our mind, that is what is multiplexer? So to define multiplexer, we can say that it's a digital switch. Switch means which have a multiple inputs. We can also tell them as source and have single outputs. So that's why this is known as a switch. It have multiple inputs and only single outputs are there. And that multiplexer device is going to select a particular one input with its output line. And to determine which input is going to be selected at a particular time, some select lines are going to be used. If we observe this side, a block diagram of a multiplexer, we can see that there are multiple number of inputs are there. They are also named as source. And the output is only one. It is fixed. And it have some select line. So the select line will take the decision that which input line is going to select at the output at a particular time. And the relation between the select line and the input line is such that if the select line is n, then the input should be maximum 2 to the power n, not more than that. That means if n is equals to 1, select line is equals to 1, the multiple input number that input is equals to 2. And that kind of multiplexer is known as 2 to 1 type of multiplexer. Whenever the n is equals to 2 select line, that multiplexer is known as 4 to 1 type of multiplexer. Similarly, whenever n is equals to 3, that is known as 8 to 1 type of multiplexer, and 4, 16 is to 1. We can see one thing from these types, that output is not going to change in all these cases. This is fixed to 1. But the number of input is going to change like 2, 4, 8, 16. Depends on the select line. Now, if I give a practical application or the example of a multiplexer, then we can say we have a sound system. And to act as an input of that sound system, we have multiple sources. I can play a music through a mobile phone. I can play music through my laptops. I can connect with my satellites, that's a set-top box or whatever it is. I can connect with a digital TV. But the thing is, here multiple sources are there, but only one destination is there. That is the sound system. So at a time, we can connect any of these sources. That means at a time, either I can connect a mobile phone, music player, or laptop, or digital satellites, or the digital cable TV. Now, we will decide that we should connect some switch, and the switch is going to be decided that at a moment, which source is connected, which device is connected with the sound system. That is the role of the select line. Say if I assign that whenever the select line is 0, 0, my music player is going to be connected with the destination. So whenever I'll select that source select line is 0, 0, the music player will be connected. When it is 0, 1, laptop, 1, 0, satellite, and like this way. So this is the typical applications of the multiplexer. We are multiplexing the signals. Signals means the input signals. We can say this is the typical examples of a time domain multiplexing. At a time, one input source can be connected with the destination. Right? So this is the typical application of the multiplexer. Now, if we are going to design that multiplexer, the basic multiplexer is 2 to 1 line multiplexer because n is equals to 1. We are considering n is equals to 1. That means the number of select line is equals to 1. So definitely the input should be 2 to the power n. That means 2 to the power 1. So 2 inputs are there and 1 output is there. And the basic multiplexer is 2 to 1 multiplexer. And if I see this 2 to 1 line multiplexer is like a switch. It's a digital switch, on off switch. Whenever a select line is equals to 0, one input is connected. Whenever the select line equals to 1, another input is connected. So in this diagram, we have two inputs and we have named this I0 and I1. We have one output, that is Q. And we have connect one select line, that is A. I already said we are selecting that select line, that is N, number of select line equals to 1. So only one select line is there and two inputs are there, that those are I0 and I1. So if I going to observe the truth table or logic table of this kind of multiplexer, then it will be looks like whenever the A is 0 for the first 4 combinations, the Q, that is the output, will follow the same pattern as the I1 is connected. See, whenever the A is 0, I1 is 0, output is 0, I1 is 1, output is 1. That means whenever the select line A is equals to 0, the multiplexer connected with the input line I1, the I0 is not connected. Similarly, for the last 4 combinations, whenever the A is equals to 1, we can observe that the output will follow the same pattern of I0, because at that time, the output is connected with the input I0. So it's a very simple, so like a switch. If I press it as 0, it will connect with I1. If I press it with 1, it will connect with I0. If I'm going to write down the equation for that output, it is a very simple equation, that is A bar I1 plus A I0. Because A bar, why it is A bar I1? Because whenever the A is equals to 0, the I1 is connected. Whenever the A is equals to 1, I0 is connected. So that's why it's A bar I1 plus A I0. So if I'm going to design that, so the circuit is very simple, right? 2 inputs are there and one select line is there. So A bar I0, here I'll replace I0 as a D0 and A as a select line. So just we'll connect a NOT gate with this select line. So it will be just S bar, and D0 is the first input line and we'll connect it through a AND gate. So in this part, at the output of this AND gate, we'll get D0 S bar, the first part. In this side, we have directly connected the select line as well as the D1 input. So the output of the second AND gate is D1S, right? So we'll get two component. One is the D0 S bar and second one is the D1S. Now our equation is what? The D0 S bar plus D1S. So just connect the OR gate, and by connecting this OR gate, we will get the equation is D0 S bar plus D1S. So what will happen whenever the select input is equals to 0? This input, the first input of the first AND gate is equals to 1 because it is connected via a NOT gate. And here in the second AND gate, this input is equals to 0. And we know from the truth table of the AND gate that whenever we'll forcefully make a 1 input is equals to 1, the AND gate output will follow the second input. So once I forcefully make the first AND gate 1 input is equals to 1, so whatever be the D0 content, it will be given by this. And here, whenever we'll forcefully make this input equals to 0, then what will happen? The D1, whatever be the D1 content, the output of this AND gate is completely equals to 0. So we'll eliminate the D1 part, we'll connect the D0 part. And now the OR gate is there, and truth table of the OR gate is 0, 0, 0, 0 1 0 0 1 1, sorry, 1 0 1 1 1 1. So one input is completely 0. So whatever be this input, it will be percolated in the output. So these connections is looks like a 2 to 1 type of the multiplexer. It's a very simple one. Moving to the higher one, that is 4 to 1 channel multiplexer. What does it signifies 4 to 1 channel? That means 4 inputs are there and output is fixed for the multiplexer, that is 1. So as the 4 inputs are there, so we can find out that how many select line is required, and that is equals to 2. 2 select line is required. Because n is equals to 2, to 2 to the power n to the power 2 is equals to 4. So 4 to 1 line multiplexer have only 2 select line. So this diagram, I've connect 4 input connections, that is capital A, capital B, capital C, and capital D. I have 2 select line, that is small a and small b, and we have only one output, that is Q. Now, the select line, as I told, that the select line is going to define that which input is connected to the output at a particular time. Now, in the first diagram, we observe that whenever both the select lines, small a and small b, is equals to 0 and 0, the capital A, the first input, is connected to the output. So rest of the output is not connected. So whatever be the content, whatever be the value is there in the B, C, and D input, that is not going to reflected in the output because only the A is connected. Simply, if I move to the second diagram, whenever the select line configuration is 0, 1, that is small b equals to 0, small a equals to 1, then we can observe the B input is connected, the second input is connected. So whatever be the input configuration is there in the B, that will be reflected in the output. Go for the next one. Whenever this configuration is 1 0, that means the small b is equals to 1 and the small a is equals to 0. Third input, that is the C, is connected with the output and the other are disconnected. So whatever be the conditions, either 0 and 1, whatever, that will be reflected in the Q. Q means output. The last one, whenever both the select lines are 1 1, the fourth input, that is the capital D, is now connected to the output part. Now, if I going to draw the truth table for this 4 to 1 channel multiplexer, how it is looks like? We have a 2 selects line, small b and small a. We have a 4 inputs line, capital D, capital C, capital B, capital A. We have a 1 input output line, that is Q. Now, once the small a and small b, both the select line equals to 0 0, which input is connected? From this diagram, we can observe the A is connected. So we can put a don't care conditions for the rest of the input, that is capital D, capital C, capital B, because those input are not at all connected with the output. So we can don't care those things. So whatever be the conditions of the A, if A is equals to 1, we will get 1 in the output section. Similarly, if I change the select pin as a 0, 1, then from the second diagram, you can clearly observe that the input B is now connected with the output. So we can put a don't care mark in the capital D, capital C, and capital A input because they are not at all connected. And if the B input is equals to 1, the output should be reflected as the 1, whatever be the conditions of the input B. Go for the next one. If the select line is 1 and 0, don't care conditions are input D, input B, input A, because now it is connected only with the C input and the output will be reflected the conditions of C. At the last, when both the select lines are 1 1, it is connected with the D. So the don't care is A, B, C. So if I going to find out the equations for this 4 to 1 channel multiplexer, then it is looks like a bar small b bar into capital A plus small b bar capital B plus small a bar small b capital C plus small b capital D. Where from we'll get this? Because if I take the first condition, whenever both the select line small a and small b are 0, 0, only A input is connected. So from the first condition, we will get this first value, first product, that is a bar, small a bar rather, small b bar, capital A, because the conditions of the select line is 0, 0. So 0 means a bar. So a bar, b bar, capital A. For the second conditions, whenever the select line is 0, 1, that means the small b is 0 and small a is equals to 1. The b is connected. So here the equations is small a, b bar, capital B. Similarly, for the rest of the two part, in the third one, it is 1, 0. So that's why B capital A, small a bar C, and the final one is both are 1. So it's a B capital D. So if we are going to design this multiplexer, 4 to 1 channel multiplexer, then it's looks like this. We can observe here 4 numbers of AND gate is required, because if I go back to the previous slide, if I look into these equations, we observe that 4 products are there, and we know that product can be realized by AND gate. So as the 4 products are there, so 4 AND gates are required: number 1, number 2, number 3, and number 4. And all these products are in summation, so we need an OR gate. And individual of that product have 3 variables. Go back to the previous slide. So these 3 variables, right? Small a, small b, and capital A. So all these AND gates should be 3 input AND gate. And as the 4 products are there, so we need a OR gate that should be 4 input OR gate. So the connections are small a bar, small b bar, capital A. So we'll connect small a bar, we'll connect small b bar, A. Second product is a bar, b, capital B. So a bar, b, capital B. Similarly, you'll go for the C. Similarly, you'll go for the D. And all this AND gate output is connected through our OR gate, and we'll get the output Q. If I'm going to realize these things with the help of a simulator, so this one, I have designed the same thing via a simulator. And here I choose the 4 AND gate. We can observe here, that is a U1, U2, U3, and U4. And we take a OR gate, that is 4 input OR gate, that is U5. We take 4 inputs as a switch, 0, 1 switch, and named it as D0, D1, D2, D3. We also take 2 other switch, which will be act as a select line, and named it as S0 and S1. And we have only one output, and we'll connect a digital output, 0, 1 output over here. Now, as we know that first case, both the select lines should be 0. So see the connections. The number 3 wire is connected with the S0 bar. Number 4 wire is connected with the S1 bar. And number 5 wire is connected with the D0, this one. So the input of this U1, the first AND gate, is S0 bar, S1 bar, D0. Similarly, for the U2, the number 1 input is connected with S0 bar. You can observe here. Number 2 input is connected via line number 6. with S1 and the third input is connected via D1. So the equation for this next AND gate is equals to S0 bar S1 D1. Similarly, for the third AND gate, it is connected with S1, this where S1 S0 and S1 bar, this line is 1 bar, and the D2 input. So the equation for the third AND gate is equals to S1 bar S0 D2. And the last AND gate, it is connected with S1, S0 and D3. So the product of the fourth AND gate is the S1, S0 and D3. And all these outputs, all these output of the 4 AND gates are connected with the OR gate. So via the line number 9, 10, 11, 12. And we have a one output, that is I0, 1. If we simulate this circuit, what we observe? See, whenever the select line, both the select lines are 0, 0, then as per our discussions, our D0 input should connect and all other input, that is D1, D2, D3 should be disconnected. Check one by one. If I change the D1 part, did the output is going to be changed? If D1 is 0, output is 0. If D1 is 1, output is also 0. So no change. If I take the D2, whenever D2 is 1, output is 0. Whenever the D2 is 0, output is again 0. No variations there. Take the D3, whenever the D3 is 0, output is 0. Whenever the D3 is 1, output is again 0. No change. What about the D0? Currently the D0 is 0 and output is 0. If I change it 1, now see the change. Output is again here, 1 is there. So if I change the D0, the same manner, the output is going to be changed. So the first point is validated over here. Whenever the both the select lines are 0, 0, first input connections, that is D0 is connected. Go for the second one. 0, 1, right? 0, 1. First 0, 1, select line 0, 1. Then D1 should be connected. Currently, you will observe the 1 is there because D1 is 1. If I change it, the D1 is equals to 0. See, the output is again 0. So if I change the D1, 0, 1 and 0, 1, see, by the same conditions, the output is going to change. Right? What about the other inputs? Let's see. D0, 0, output 1. D0, 1, output 1. No change. D2, 0, output 1. D2, 1, output 1. No change. D3, 1, output 0, 1, sorry. D3, 0, output 1. So no variations. Only the output will vary with the D1 input. Go for the next step. Now the select line is 1, 0. 1, 0. So as per the theoretical knowledge, then the D2 should be connected. Currently the D2 is equals to 0 and output is 0. Let's change it. D1 is 1, output is 1. D2 is 1, output is 1. So the output is directly vary with the D2 part. What about the other input? I change the D0, no changes is there. If I change the D1, no changes is there. If I change the D3, no changes is there. Only the D2 is now currently connected. Now the last case, both the output select lines are 1, 1. So as per the knowledge, D3 should be connected. If I change the D3 value, see the output is changed. Low, low, high, low. Right? And whatever the others, there is no change. There is no change on the D1. There is no change on the D0. Only it will be changed as per the D3 because the select line is 1, 1. So we can say this circuit is working perfectly as a 4 to 1 multiplexer. Okay. So by this way, by selecting a particular combinations by using the select line, we can connect one input at a time with the output. If I increase the number of select line, this is for the n number of select line equals to 2. That's why it is 4 to 1. If I increase the number of select line, now it is 3. It should be 8:1 multiplexer. If the number of input is equals to, for the select line equals to 4, it should be 16:1 multiplexer. If it is 5, 32:1. If it is 6, 64:1. As per the requirement, we have to choose that particular input combinations. And by the same procedure, we can also able to design the rest of the higher order multiplexer. Okay. So this session is up to this much. So thank you very much.